Question number 3. Suppose you just completed a non-stop bicycle trip of 5.5 kilometers. You know that each wheel of your bicycle has a radius of 35 centimeters. About how many times did each wheel turn during this trip? Okay, let's draw a picture here. Say this is the road that you are on, and your bicycle wheel is right here. The wheel has a radius. The radius we know is 35 centimeters, okay? And when the wheel goes forward, there's always a point that's touching the floor. And as you go forward, this same point may be already here. So the wheels keep turning forward. How many times did the wheel turn? So going from this point, and as the wheel goes forward, that point will go up and down until it completes a full circle, that the point comes back onto the ground. And how far is this distance? This distance is for the wheel to go a complete cycle. And we know what is the complete cycle for the wheel. That is the perimeter of the wheel. Perimeter of the wheel is 2 pi multiply the radius. So this one we can calculate using the known information. 35 centimeters equals to, there's a conversion that we need to do here, is 0.35 meters. So the perimeter is 2 pi multiply 0.35 meters. Pi, we know, is a constant. We can use 3.14 to replace it. So one turn for the wheel to be on the ground is this many meters. Okay, now total we have traveled 5.5 kilometers. So how many turns that we have to do, which means is 5.5 kilometers is how many times of each turn. So how many times that we have to turn? Number of turns equals to the total distance divided by each turn distance, right? So the total distance is 5.5 kilometers. We need to convert that too. So because the perimeter we have been using meters as the unit, 5.5 is 5,500 meters. Now we have the same unit, then we can divide them. Total distance is 5,500 meters. And each turn distance is just the perimeter. Now you can calculate this number to find out how many turns that you have to do for your bicycle. Number 4. Suppose that you bought a carton of 36 one-foot sections of decorative garden fencing to enclose a rectangular flower garden. What is the largest garden you can enclose with the fencing that you bought? So this one, before we know any method to do optimization, we can just list all the possibilities, okay? So we can list a table here. And we want to have length, we're going to have width, and also the area. And we can vary the length and then getting the corresponding width because the total perimeter is fixed. We vary the length and therefore we are varying the width as well, then the area will be changing. Then we can go through every single possible possibilities to find out which combination has the largest area. So for example, the length can be, okay, first of all, if a rectangle has a perimeter of 36, the two adjacent side add them up is 36 divided by 2, which is 18. Okay, these two sides add up to be 18. So therefore, and the minimum number of width and length has to be 1, right? If length maximized is 17, the width can only be 1 because the addition of the two has to be 18. So in this case, if length is the maximum and width is the minimum, the area is 17. So then we can continue down, varying this. Is length can be 17, 16, 15, 14, 13, 12, 11, 10, and 9. Okay, once you reach 9, and then if we vary the length to be 8, then we'll come back. Okay, if we finish the width length, so 1, 2, 3, 4, 5, 6, 7, 8, 9. If the length becomes 8, and then the width becomes 10, then we come back to the same combination. So there is no need to continue down the table, because the length and width can interchange. It doesn't matter which is which. The combination is the important thing. So for the second combination, we have multiply them together is 32, 45, 64. This is 65. 65, and then 72, 77, 80, 81. So now you will find that when they are a square, which means width and length are the same, the area is the biggest.